Hi folks, this is the second lesson on solving three equations and three unknowns. So let's get to an example of such a system of equations. So here I've got three linear equations and three unknowns. Now remember, what makes an equation linear is the fact that the exponents on all the unknowns is 1. Okay, so this here would be a linear combination of variables x, y, and z, and that needs to be equal to 5. And this linear combination is equal to 11. This linear combination is equal to -4. Okay, so how can we apply the methods we used for two equations to three equations? So let's just recall the elementary operations that we're allowed to use to solve these equations. Okay, I can interchange the equations. Not something I'm going to do right now, but as I said earlier, this will come into play later on. Okay, so I'm allowed to multiply an equation, both sides of an equation, by a non-zero constant, and I'm allowed to create new equations by adding or subtracting the existing ones. Okay, so this is what I'm allowed to do. That will not affect the values of x, y, and z that are going to satisfy all three equations. Okay, so we're going to do exactly what we did before, is we're going to try to eliminate a variable. Now when I look here, I notice that with equations 1 and 2, it would be very easy to eliminate variable y. So let's just do that and see where it leads us. Okay, so I'm going to take equation 1, okay, which is 2x plus y minus 3z equals -5. Now notice here I'm always going to be labeling my equations. Okay, this becomes even more important when we're working with 3 than it was when we were working with 2 equations. Okay, it makes the solution much clearer. Okay, and I'll take equation 2 as is. I won't actually multiply either of them. Okay, plus 4z equals 11. And if I add the two equations, I'll be able to eliminate one of the variables. Okay, so 2x plus x, so we've got 3x, and here y minus y is 0. Here we have -3z plus 4z, so plus z, and then here we have -5 plus 11 is 6. Okay, now we notice that by eliminating the y's, I still have an equation in two variables, so I can't solve this equation. Okay, the extra step that we need to do when solving a system of three equations is we are going to repeat this operation with another pair of equations. Is we're going to take two other equations, okay, and eliminate the same variable. Okay, so that is the important step here, is when we take another pair of equations, we have to eliminate the same variable. In other words, we have to eliminate, in this case here, variable y. Okay, so I need to bring in equation 3, and I see that I can use either equation 2 or 1 quite easily to eliminate the y in equation 3. So let's take equation 1, okay, and I'll have to multiply equation 1 by 2. Okay, so 2 times equation 1. Okay, by the way, I'm going to reuse this equation a little later on, so I now need to label it, but it is a whole new equation, so I'm now going to label that equation 4. Okay, so let me take 2 times equation 1, and what do we get? We get 4x plus 2y minus 6z equals -10. And then I'm going to work with equation 3, which is 3x minus 2y minus z equals -4. Okay, and again I can add these two equations to eliminate the y variable one more time. So here 4 plus 3, I have 7x. This gives me 0. I have -6 minus 1 minus 7z, and here we have -10 minus 4, -14. Okay, this new equation that I formed by multiplying equations and adding or subtracting them, again, both elementary operations, I can now call equation 5. But now I see that what I've created is a new system of equations, okay, an equation of two equations in two unknowns, x and z. So that's why it was important that if we eliminated y in the first instance, we had to also eliminate y in the second, so that I ended up with two equations and two unknowns. Okay. Now this is where I could certainly, start solving this new system of equations, which again, because these were all elementary operations, the x and z's which satisfy these two equations will be the same as the x and z's which satisfy the original equations. But if you look closely here, I could make my life a lot simpler by replacing equation 5 by the equation gotten by just dividing both sides of the equation by 7. So this now becomes x minus z equals -2. A much easier equation to work with. So again, if we see some nice common factors that can be removed, please do it. Makes your life simpler, because now solving for and the new 5 here becomes much easier. I actually don't have to do any new multiplication. So I'll take equation 4, 3x plus z equals 6, and now I'll take the transformed equation 5, x minus z equals -2, and I can add them to now eliminate the z variable. Oh, we'll just move that up. So here 3x plus x is 4x. This goes to 0, and here I'm left with 6 minus 2 is 4, and I just determined that x is equal to 1. And now we're going to do what we did previously when two equations and two unknowns. Once I know one variable, I can go back and start determining the other ones. Okay, so I can now use equation 5 to solve for z, because I know x is equal to 1 minus z equals -2. So let's bring the z to the other side to make it positive, and then 1 plus 2 is equal to 3. Oh, sorry, let's show you that there. Okay, so I just brought the negative z to the other side, make it positive, and then the -2 to the other side to make it 1 plus 2 equals 3. And now that I have both x and z, I can now go back up to one of these equations here and solve for y. So I'll take equation 1. That seems to be the simplest one. So if I take equation 1 here, so I have 2 times x, which I now know is equal to 1, plus y, which is still unknown, minus 3z, and z now is equal to 3. So I can input that. That's equal to -5, so I'm left with 2 minus 9 is -7, so y minus 7 equals -5, and so y is just equal to -5 plus 7, which is 2. Okay, so these are the solutions to my system of equations. Okay, so let's just recap the steps that we follow. Okay, so step 1, okay, we have to choose two equations to eliminate a variable. Okay, step 2, okay, is choose another pair to eliminate the same variable. So a new pair of equations to eliminate the same variable. And then step 3 is to solve the resultant system of two equations and two unknowns. So solve the resultant system of two equations and two unknowns. Okay, and then finally step 4, okay, is to take these two values and input them into one of the equations to solve for the third variable. So input the two answers into an equation, into an equation to solve for the third variable. Okay, and this is the procedure we use to solve for 3 equations and 3 unknowns. Now, one thing you'll realize is that sorry, my screen just went dead, so I'm just going to wait for it to come back on. Okay, so one thing we realize is that there's a lot of algebra going on in a question like this. Okay, so might there be a way to clean up all this work? I mean, doing this for 2 equations and 2 unknowns, not so bad. Here, doing this with 3 equations and 3 unknowns, and keep in mind that the algebra was all very nice. These numbers were chosen so that, you didn't end up with tons of fractions, but still with that, quite a bit of writing. Okay, so what we're going to look at in the next lesson is how can we clean this up? Is there another way to express the solution that allows us to save some time in writing out all these equations? Okay, so that's for the next lesson.